In this video, we're going to take a look at using forward propagation, backward propagation, and then describe stochastic gradient descent. We'll start off by talking about and building simplified one-bit gradients, learning rates, using those gradients to update the model, propagating, and then we'll extend these concepts to stochastic gradient descent. We'll dive right in and look at code and how this is done. Now this is going to be a very simplified machine learning model in two variables, and we'll start off by plotting a target point. We're going to be using Matplotlib's animation library as our main learning driving loop so that you can actively visualize what we're working on. Now we have a target X and a target Y. These are going to be our output variables we're looking for, and we're going to set them both to 0.9, so they're just known values. And then we're going to make a Matplotlib figure, an axis, and then we're going to set it ranged 0 to 1, and then actually plot a red dot on the screen. So this red dot is our goal that we're going to be seeking with machine learning, and you can see it right there. So here's a random starting point. And machine learning is always a lot like this. Random initialization of numbers that we're trying to learn. So we'll take an @x and an @y that are random initial starting points and take a look at them. We can see right away that the x is relatively close at 0.91 and the y is relatively far away at 0.07. And now we're going to learn our way to the target values of 0.9 and 0.9. At each step we're going to compute a loss function or error, and that's the distance we are away from the target. And then we'll compute a one-bit gradient, which is really just a sign, positive or negative in the direction we need to head. And then we'll learn with a learning rate and update the position that we're actually at each step, each time, and then plot a line showing us 2 points. One, the actual target point, and the other, the point where we're at right now. And so learning is really just doing this. At each step, each frame, we're going to be updating our parameters and then get closer to the target value. Now, admittedly, this is a bit of a trivial model since we know the exact answer, and in a larger model, there'd be many more parameters. So here's what we do. We compute the error or loss at each step. We see where we're at compared to where we need to be and simply subtract. And then we compute a very simple kind of gradient, a one-bit gradient that's just a sign. Do we need to go in the positive direction or the negative direction? In a real machine learning model, this would be done for you with more sophisticated math, but here we're just trying to demystify it. All you need to know is that the gradient is a multiplier that takes your learning rate and heads it in the right direction. Now I'm introducing another concept here of a decayed learning rate. Each step we're going to lower the learning rate. This keeps you from bouncing around and oscillating around the target, particularly as you get closer and need smaller values. And then right here, this is the actual machine learning. At each step, we plot the point we're at minus the learning rate times the gradient. We simply update where we're at based on how wrong we are. And then with those updated x and y values, we just plot a line and then save our learn position. So here's the animation loop, and this is the main learning loop. We're going to draw 100 frames to watch it learn a little bit, and then we're going to have a 20 millisecond interval. And Matplotlib will actually render this out for us into a function, starting from the initializer, which is 2 points that are at the end of the line initially, and then it'll loop through that learning function at each step. And then we can see it as an actual graphic on screen. This is actually a neat way to visualize what machine learning is actually doing by watching it learn. So we'll go ahead and watch the video loop a little bit. And you can see our current point, the point where we're at, iterating and converging towards the target point. Now, admittedly, this isn't the world's most sophisticated version of machine learning, but you can actually get a sense as to what's really going on under the hood. The model runs over and over, iteratively in a loop, updating the values with a learning rate times a gradient to head in the right direction to get to the right value. Stochastic gradient descent is simply a method of sampling batches to allow machine learning to iterate over large data sets. And this would make learning impossible if you didn't have all of the data that could fit in memory. So stochastic gradient descent is a way to sample down that data so you can actually fit it in your memory and work with it. It's the same basic idea we did here. At each piece of data, you run the model, you figure out the loss or how wrong you are, you update by the learning rate, and then you try again. But the important thing to know, and you saw it in our output in our animation, is that machine learning is inexact. It isn't Boolean logic. It always gives approximations and probable answers. When you saw our little red dots grow, they never really made it all the way together. Now, a lot of that's because the learning rate was too small, and we could have just run it for much, much longer and watched them converge. But this is really true in any large-scale machine learning model. It's not and or and not. It's not simple Boolean logic. It's mathematical, probability-style logic. And so you need to bear this in mind when you're using your models. In the next video, we'll take a look at a classic machine learning method, logistic regression, but do so with a neural network mindset.